Good morning, my friends. Today is Monday, April the 6th, and today we are going to talk about the concept of electric power. Now, if you've ever bought a light bulb or looked at the back of a stereo system or a television or anything that runs on electricity, there's a power rating at the back of this item. Or in the case of a light bulb, for example, it's usually printed right on the glass itself. And so it's a 60-watt bulb or a 75-watt bulb. Or these days, you can get those little curlicue fluorescent bulbs that are, use less electric power. So what exactly is electric power? Now, remember, we've talked about power in terms of energy, but specifically because electricity is a form of energy, it provides power, or I should say more accurately, it uses power. So how do we derive this idea? Where does this come from? Okay, well, it's actually, believe it or not, a fairly simple relationship. So we're going to start with two formulas, okay? The formula for voltage, which is work divided by charge, and the formula for current, which is charge divided by time, okay? Both of those are formulas that we've used in the past, okay? And so we start with this formula and this formula, and we then multiply the voltage that we have here and the current that we have here together. And since voltage is equal to work divided by charge, work times charge, and because current is charge times time, that gives us work times charge over charge times time. And I don't know why there's an N there. All right, let's get rid of that. Typographical error, sorry. And that equals work over time because the charge literally cancels out. And so that leaves us with a formula of voltage times current equals electric power. And that's what we're talking about here. The units of electric power are literally a volt amp, which is, think about that, voltage times current, volt amps. But we know that the units of power are watts. And so the unit of electrical power, just like any other kind of power, is a watt. So how would we use this in an example problem? Okay, so that brings us to example number 8 here. And the question is going to be to calculate how much power comes out of or is used by a light bulb. All right, so in this case, specifically, we say what current flows through a 75-watt light bulb connected to a 120-volt outlet. Okay, what current flows through a 75-watt light bulb connected to a 120-volt outlet? So this is a very practical example for those of you who are, changing light bulbs in your house or that sort of thing. How much power is this thing going to use versus the 75-watt light bulb versus, or how much current is it going to draw versus a 60-watt light bulb or a 40-watt light bulb or something along those lines. So how do we solve for this? All right. Well, in terms of this, again, we always start with a laundry list. All right. The first thing, the question mark here is what is the current being used here? We know that the light bulb has a power rating of 75 watts, okay, which should not pop up. There it is. So the power is 75 watts. The voltage in most houses is around 110 volts, but we'll use 120 here just for kicks and giggles. And so how do we calculate this? Well, we know that the formula for electric power is P equals V times I. All right, so there it is. at this point, I know that I'm going to need to rearrange this formula algebraically to solve for the current. So I is equal to power divided by voltage. So 75 watts divided by 120 volts leaves me with 0.625 amps. Okay, so there it is. Here is my answer. All right, so 0.625 amps. All right, so there we are. That is electric power. It's a pretty straightforward formula, fairly easy, and so this is going to be a very short video. All right, your homework for today, which needs to be turned in by end of business today. So by dinner time or so, please, is to do questions 11 through 12. So just two questions. Nope, I lied. It's 12 through 13. I changed it around. Sorry. So 12 through 13 on the electricity homework sheet. All right, gentlemen. Happy Monday. I will talk to you later. And oh, by the way, welcome to Holy Week.